Hello, my name is Dragan, and I will show you how to construct a simple model in Groundwater Vistas. We will use the example from Mary P. Anderson book. On one, this is the sketch. So on the north there is a river with elevation of 1000 meters. On the south it's a green swamp with elevation of 100 meters, and here is the cross section. And we will construct a simple model based on this. First go to Groundwater Vistas, File, New. Let's see, it's 8,500 meters from this point to this point. It's 10,000 meters basically. So as a trick we will assign only two rows and two columns. You will see later why we do that. And sand and gravel hydraulic conductivity is 50 meters per day. We will change that in Groundwater Vistas. And since this is the steady state model, that is all what we will change. Here it is. Now we will import the map. We did a simple map with AutoCAD in DXF format. Just need to navigate to. So we will enter DXF map. And this is DXF map in real coordinates. Now we will go to grid, enlarge the grid, now we will set up the cell spacing. Set cell spacing. Since this is 10,000 meters, let's say that each cell can be 200 meters. So we will set up here 200 meters, set cell spacing 200 meters. We will delete this row, right mouse click, then we will click to add more rows. You see the number. Okay. While we are doing that, okay, we finished. We will delete the column. That's the reason why we put only two columns and two rows. Okay. We'll increase a little bit. Okay, now we will add the boundary condition. In this model it's a river, which will be represented at constant head of 1000 meters, and elevation of swamp also 1000 meters. But first we will change the bottom and top elevation of the model. We will go to properties, bottom elevation. We first need to do this. Okay. And the bottom elevation is 980 meters. Now we will go to top elevation. It will be 1100. Now we will do the save. 143. Okay, we will not change the MODFLOW path names. And now we will go to boundary condition, constant head. Assign 1000 here. Value at the end of line also 1000. And we will do the same on the south border of model. 1000. 1000. And now we need to add the recharge. Aerial recharge, according to this example, is 0.001 meters per day. We will go to boundary conditions. Now we will go to properties, recharge. .001, 3 zeros just to check. No, 2 zeros. Okay. And this is the simple model. We will save it, run it. We need to find appropriate folder. Okay. Okay, the model crashes, and this is also good to know. It's important that we save the model. We'll run it again. It's very simple, and I know why it's crashed. It's good that this shows. Okay, we need to again. Okay. We will save it because we didn't set up initial heads. This is why the model crashed. Let's go to MODFLOW, package options, initial heads, and initial heads will be 100. Okay. Now the model should run. Yeah, it's okay. Now we will. Okay, now you see the profile of it's practically the same as the results get from this book. This is cross section along column number 10. Everywhere it's the same, and the rest we need to add one well. And this is the boundary condition. Well should be minus because it's extraction 15,000. Now run the model. And here is the grid. Here is the results. We will turn off the grid just to see better. We will increase the font of labels of isolines. Okay, 12 is okay. Set up interval as 1. Okay. For some reason isolines disappear. Okay, we probably did something wrong. We will change it. Yeah, we did this. So this is important. We did the mistake, and you see how the model reacts when you enter the mistake. Now everything will be okay. Yes. And this is the simple model from the Mary P. Anderson book. We will do in the second part of this exercise, we will do some boundary check. Okay, thank you.